this video, we're going to go through some web challenges that put up by Hack the Box in their event Cyber Apocalypse 2023. First one we'll start with is TrapTrack. And so we can see a description. It's kind of a bit of a thematic, but essentially we need to try to break into a website. So I've already downloaded the Docker files, and we're going to use burp and browse to it. But before that, I've spun up a Docker container running the app. So if I go to port here, I can see that it's running on localhost 1337. So if I go here, and this is just a much easier way to go through this exercise rather than doing it remotely. But yeah, we can see localhost, and we have username and password, and this is the beginning of the app. So what we'll do is we'll do a quick code review, kind of go through it. When I go bottom up. So we have a worker here with the main function. So there's a connection to Redis. It's going to get a work item by popping a value from Redis queue and then getting some data from the queue. Looks like it's base 64 encoded, so it's going to base 64 decode it, and then we're going to use pickle. So this kind of flagged it for me that there's some kind of deserialization opportunity probably. Then there's some incrementers and decrementers and field setters, and then there's kind of a run worker function, which so it gets the worker if it's no job, no ops, grabs, increments a field, gets a URL, and then makes a request. So go into here, you can see it's calling PyCurl. It's making a request, and it's returning the response. Unfortunately, it's not doing anything with the response. It's just setting it 1 or 0. So this kind of got me thinking. Maybe initially we could like read the flag. So something like, I think this would work. I think it's in the root directory. Can't open flag. So let's just make sure that you know why? It's because it's not. Yeah. So I was thinking something like this: file root.flag. Except the challenge is I'm actually as root. So I think if I create a test user, where am I? Test, and then I try to do curl file root.flag. Couldn't open because it's denied. I think the same thing if I do root.flag permission denied. And so this is all in the Docker container. You can see that the app will actually run as like under a different profile. I think www data rather than just go to the Docker file here. Yeah, so www data will be what the app runs at. And if I go to the supervisor, Flask is a different user, Redis is a user, and then yeah, so it's not going to have root access. So we're going to need to do, if I go back to the Docker file, I think there's a read flag. Yeah, so there's a read flag binary that should be available at root with the permissions to run. So we'll actually need to run an executable where essentially to solve this challenge, we'll need to get remote code execution to be able to view the flag. So that got me thinking. Maybe with request, it's something to do with Redis, but we'll come back to that. And then essentially, this worker runs every 10 seconds, so it looks like it just pops a job off the queue and processes it. Health check is the command that we just saw. Instance, I don't know what that is. Flask sessions. So this is probably, yeah, the Flask session. So we've logged in, and I bet you if I go to the history here, we have a session ID or something that gets set. Okay, maybe it's happening to just see there's a cookie. Okay, well, there's already a session. I haven't, so it's the first, so something's already set up. And then now we're getting into the main app. We have a utilities function, just doing some random stuff. The main app itself, we go bottom up. So some error handling, a URL, a web API, and then the main API. Using Flash sessions, and then just some other config stuff for Redis in the database. This database file just has some model, and essentially every time we restart the app, it'll just give us a clean database, which is nice for testing. Here's some configuration stuff. So the username, password are admin, and so this challenge isn't about trying to get bypass login. So this is the same locally as it is remote. And then cache. So this is a method. This basically gives all the functions that deal with Redis. So we have get a list of jobs from Redis keys, get some IDs, and then we can kind of create a job queue here. So this is where we're pushing data into Redis. So it takes the format of job ID, trap name, trap URL, and then some other variables. It gets pickled and then base64 encoded and loaded into Redis. So, and then it also increments, it adds to a queue, the job ID to a queue. So this is what's used for processing, and this is what's used for data storage. And then this just loads a job from the queue. Templates, so we have a login, an admin page. This is a backend challenge, so we don't got to worry about the static stuff. Next interesting thing is root. So we have our logout, our status, which basically gets job queue. And if we remember, this is just grabbing the current value that's loaded into Redis. So just gives us a status update. Tracks delete, just delete something in the database. Tracks add, we'll add something. So this is important because we're going to want to add it. We need a URL, a name, a URL, and we're going to call this create job, which essentially will return the payload that we add. Then it adds it to our database. It just says successfully added. Tracks list, so just get a list of tracks. And an admin page is just the web route. So these are all prefixed by API. This is just straight admin. We can go to visit it, log in, and okay. So I went through this really quick, but generally, I think the first step is I think what we need to do is we need to, step one, be able to send commands to Redis to poison the cache. And then step two is once it's poisoned, pickle our own data object, and so that it will run a command. And I think basically we go to deserialization and hat tricks. It's kind of a well-known thing. So there's nothing too tricky. The biggest challenge, I guess, for this challenge is going to be just figuring out how to communicate with Redis, because the pickling is pretty straightforward. We just create any object. We set a reduce function. It's kind of like a magic function. We set a system call, and then we pass an argument that we want that system call to be. It's going to we base64 encode it, and then when it gets unpickled, essentially it's going to pass this argument to this function to run it. And so we'll get code execution. So Redis, how do we communicate with Redis? So we're dealing with we have curl, PyCurl. So what do we look at? PyCurl supported protocols. So we have a list of protocols here. So we know that this was a nicer list. So we have a bunch of things here that are kind of unique. One thing that I'm interested in is I know Redis works off the text protocol using binary, so I wonder if a telnet command would work. So if we're in here, curl telnet localhost 6379 is Redis, and we want to list keys. Let's say key star. Let's see if this key star. Okay, so it did open up a connection. This didn't pass it, but I do have an interactive terminal. Get all jobs. Yeah, so we can start interacting with Redis right through curl. Now this does require interaction, and this Python script won't allow that. So it's interesting, but it's probably not gonna work. No, it's definitely not gonna work, and I'm not gonna go through in this video. I'm not gonna go through how I debug that, but essentially here we can see that telnet would work. So let's just see what other protocols. I don't know what dict is, but we'll just give it a shot because it's at the front there. Unknown command keys with R at the beginning. So something went through. Do %0D for %0A for new line. See if it's giving OK. Oh, wrong number of arguments. So this is something wrong with loop curl. Let's see if I get the same thing for. Oh, it won't work because we're doing a host. We'll try gopher next. Okay, so that worked. So essentially, this is a carriage return, and this is a new line, but URL encoded. And then we can pass some Redis commands right directly inside the URL. Now this is still an interactive session, but we're going to be okay because we have 5 seconds for curl to time out. So we can play around with it now. I think the stuff listing all keys, we can also %0D, %0A, L index. If this will work. Job queue. Let's just check out what it is. Job queue. So this should show us. This should give us also return. We have one where we list 2 commands. One where we list all keys, then a second command where we get the next item in the job queue. Actually, we want the first item in the job queue. Error unknown command. So I think this needs to be URL encoded. Jobs -1. So nothing's in the queue. And here we have keys. We have a U100. So maybe the keys are 100 in jobs, and then their -1 is that there's nothing in the job queue to start so far. So this is going to be our angle essentially. What do we want to do is we'll spin up. Don't need that. We'll spin up a listener just locally here. Put a temp just so we don't screw things up. Python HTTP server. There we go. So we'll spin something up on port 8000. We'll just curl. And so that's listening. And what we will do is we will create our first. We're going to create our first, kind of play around with what we want. So essentially, we're going to want to, so we have the worker going every 10 seconds. And if we just go into Redis CLI, we have two keys, jobs and 100. I think 100 is the seeded job that was added part of the database here. So we create a job queue with Wikipedia and a URL. So this is probably just kind of base 64 encoded data related to this. So kind of thinking about this logically, what we want to do is we want to add a job with a URL that will communicate with Redis, set a key within Redis to be a malicious payload, and then push that key into the queue for processing. So what kind of payload do we need? We need a pickle object. So we need something pretty, so we can just use what we had before. I want to create a quick little solution thing here. Got rid of it. Okay, so we'll create our class P, I think it was, object. Let's do a special reduce function self, and this was going to return, so we'll make a system call where we want to curl say, and will be HTTP localhost 8000 data equals. So we want to curl our listener, and we're going to want to send it the results from read flag. So this is just a sub query. This is a sub shell, I think, inside this main shell, and so this $sign will essentially open a new command. It'll read the flag, and then it'll append it to our listener. So it should show up here with some kind of it's not, it won't be URL encoded, but well, put ORS. So I think, are we happy here? Now this needs to return a tuple, and that should be good. And then, so we need this. So what can we do? We can just do this manually, where we will create a payload that's base 64. We'll import that base 64 code pickle dumps p, and then we'll decode to UTF-8. That's good. keyboard I want. Okay, so we have this payload. So let's exit Python. Okay, let's move that from there. And I need to print the payload. That would help. So you can see it. And you know what? I need to put this in a function or put it in name. Oh, I copied it, but I didn't. Still working on the old one. Okay. There we go. So this is our pickled object. That's what we're going to want to inject. And what we're going to want to do is we're going to want to, for the purposes of the demonstration, we want to, no, we can just write it out. I'll write it out. URL is going to be, so it's going to be gopher localhost 6379 percent 0D percent 0A. We're going to want to set a hash key on jobs. So if I just pull up the Redis CLI, hget all jobs. So this is where it's running. So we have the hash key 100, and then this is the payload. So we're going to want to set a hash key on jobs. We're going to want it to be, let's do this so that way it's clear. Job ID equals 1137, just so that we don't have so many URL encoding. Then we're going to do payload. And we want to do a whole new command, so 0D percent 0A. Then we want to push something to a queue, so we're going to use our push percent 20 job queue percent 20. We want to push the job ID. So, and then let's print this. So this is going to be our URL. It's going to be Gopher protocol, where it's a new line. I'm going to set a key on jobs for 1337 as this base64 encoded string. We want to push onto the job queue our new job, which is 1337. And that job is going to curl our localhost with data. So hopefully it shows up here. Now, to do that, why don't we go through the front end just to get a sense of it. So I'll copy this. Copy our fancy URL. We're going to log in, admin. This one actually doesn't need any interception really. So we want to add a track, and we're going to add a URL. So if we add that, we can see it here. And we kind of just wait. Should be a couple seconds to show up there. While that's processing, why is this going to work? Because there it is. So it's because of this line, pickle loads. So when it's going to just grab the data and it's going to send us a flag. So now let's just do it on our main, on our instance. So I'll spawn up an instance. And cancel this. We're going to change our listener to be, I'm going to put it here. I wanted to do this. Please subscribe.mlto.dev. Data, I'm going to send that. And something tells me I'm on the wrong file. So we have it. All this should be the same. We'll just run that payload. Go for result. I'll add the track. Give me flag. Track added. And then we'll just wait. You know what? I should set up a server. I don't know if I need it. And there we go. HTTP. Now I think it's missing the brackets, but we put that in like that. Boom. So that was TrapTrack. Kind of cool that you could connect to Redis using some kind of weird protocols through curl. So if you don't have the Redis CLI, just go for it. That's it. Thanks.